Today we'll be covering the latest advances in design solutions for LED lighting from the interface level up to the overall fixture or luminaire. 3M is a leading supplier of a variety of converting materials that are used in LED lighting applications. Fabrico is a leader in flexible materials converting and advanced assembly with experience in converting a range of thermal management materials and adhesives for LED applications. The esteemed speakers for today's webinar are Joe Muska from 3M Converter Markets, Mark Zabel from 3M Electronic Materials Solutions Division, David Stankus from 3M Electrical Markets Division, and Brent Ekus from Fabrico. And now, to get the webinar started, here is Brent Ekus from Fabrico.
Thanks, Stephen. The topic for today's webinar on LED lighting design will include an introduction to various 3M materials and Fabrico converting capabilities and services, as well as some case studies where converted materials from 3M and Fabrico were used in LED applications. We'll then wrap it up with a summary and a Q&A. As you know, the use of LEDs is growing in many segments of the lighting market. Most of this growth is occurring because engineers are finding new and exciting applications where LEDs offer a better lighting solution. This market has nearly doubled in the last 5 years, with projections hitting $30 billion globally by 2022. In today's world, the advantages of LEDs are numerous and well known. These advantages have led to design engineers to find new ways to use LEDs, from outdoor lighting to dashboard and cockpit displays, as well as headlight assemblies that last longer and illuminate more of the road. Unfortunately, LEDs have one well-known disadvantage. They generate unwanted heat. Today, we're going to look at LED design and construction and the solution-driven materials that 3M and Fabrico provide. 3M has a variety of materials used in these applications, such as flame barriers, transfer tapes, VHB tapes, EMI and RFI shieldings, and thermal management materials. Thermal management is an important part of any LED fixture. 3M has a variety of thermal interface materials to help manage the heat LEDs produce. Fabrico then takes those materials, combines and converts them into a customized solution to fit your LED requirements. Next, Mark will review the thermal management of LEDs and the related 3M solutions.
Thanks, Brent. Why do LEDs get so hot? As current is applied to an LED, it generates light and heat. The light's transferred outward, while the heat is created in the base of the LED. Excessive heat leads to premature failure of the LED. This heat needs to be dissipated, and only that's accomplished using a heat sink. So, if I have a heat sink, why do I need a TIM, or thermal interface material? TIMs are an integral part that includes a heat sink or heat spreader. The TIM sits between the LED and the heat sink and provides high thermal conductivity to efficiently transfer heat to the heat sink. Without a TIM, gaps and spaces between the LED substrate and the heat sink lead to inefficient heat transfer and degradation of LED performance. When an LED overheats, it can change color, lose illumination, and eventually fail completely. As you can see in this chart, there are many different types of TIMs, and they all have pros and cons. You're probably familiar with thermal grease. Effective, sometimes messy, it doesn't bond the LED and heat sink, and it can run out. Epoxies require cure time and do not ever allow for future disassembly. Phase change materials require heat curing. Solder-type materials are difficult to use in high-scale production processes. Tapes allow for the elimination of mechanical fasteners, but are limited to gaps less than 20 mil. Die-cut pads are conformable and thick for large gap filling, but must be used in conjunction with mechanical fasteners. Air is a thermal insulator. with a K value of 0.02 watts per meter Kelvin. Air does not conduct thermal energy, it blocks it. The purpose of a TIM is to displace the air to allow for efficient thermal transfer to keep your device cool. Since materials used in the real world are never perfectly flat or smooth, it is important to use a thick enough TIM to completely fill the gap. This illustrates the gap filling capability of a 5 mil, 10 mil, and 15 mil gap fill in the same design. 3 heat sinks were applied to glass simultaneously with 50 psi of pressure for a dwell of 10 seconds. The lighter areas you see represent the air gap left from having too thin of a material in the design. Those areas are conducting no thermal energy, so remember, fill the gap. 3M offers TIMs in a variety of forms, including tapes, pads, grease, and adhesives. 3M products have proven durability, both in accelerated aging tests and in real-life external lighting applications. The benefit of using thermally conductive tape is that you eliminate the need for mechanical fasteners, saving both material and process cost. You can choose from acrylic or silicone pads. These pads can be die cut into any geometric form factor. Unique to 3M, acrylic pads provide effective heat transfer at a lower cost than silicone pads. 5590H is our go-to acrylic gap pad material. It offers 3 watts per meter Kelvin and good conformability at approximately 30% lower cost than silicone pads. The only limitation is the device must run at or under 100 C in service, but can take short-term dwells to 130 C. Thermally conductive epoxies offer permanent attachment for applications that will never require disassembly. Thermally conductive grease is effective, but hard to dispense manually in a high-scale production environment and still require mechanical fasteners. In LED displays, several different TIMs may be utilized within a single application. Over to you, David.
Okay. Thanks, Mark. There are a variety of other converted materials needed beyond thermal management materials. These materials play an important role in performance, function, reliability, and most importantly, safety. We will next cover some materials used for electrical and fire safety. UL safety standards cover electrical and fire hazard risks on everything from raw materials to components to luminaires. The coordination of these various standards ensures the safety of these electrical devices. The UL 8750 standard covers LED components within luminaires that has portions pertaining to polymeric materials used in electrical equipment with various related test methods. Enclosures play an important function of containing electrical and fire hazards within the luminaire. They must be made of either metal or highly flame retardant polymers with a UL 94 5VA rating. The integrity of the enclosure is retained by use of a 5VA material around the LEDs and between the circuit and secondary lens. This exploded view of an outdoor luminaire shows some of the luminaire components. Let me comment on the converted parts of this assembly that are circled in red. A thermal pad is used to conduct heat from the LED light engine to the housing and heat sink. Some of our thermally conductive acrylic pads do an excellent job in this application. 3M flame barrier material is used to meet enclosure requirements between the light engine and secondary optics. This flame barrier often has transfer adhesive on one or both sides, which we will cover later. The beauty of this design is that the 5VA pattern sheet allows excellent optical transmission as compared to other designs that use either a lens with flame retardant fillers or an additional glass plate. 3M has developed a flame barrier to enable luminaire designs that are optically efficient, cost-effective, and comply with UL safety standards. The white version gives maximum light output for LED luminaire, while the black version helps minimize light pollution. This thin material comes in roll form, which is easy to die cut, form, and laminate for custom applications. The 3M flame barrier FRB materials are primarily inorganic. It is kind of like an unfired ceramic that retains good flexibility with excellent flame retardant, dielectric, and thermal properties. This product family contains a variety of colors, densities, and thicknesses. This UL 94 5VA rating is very unique and significant. Let me explain more. The UL 94 V0 rating is often considered to be the highest flame rating for a plastics material. However, there are two lesser known higher performance levels above V0 in the UL 94 standard. The 5VB and 5VA levels require 10 times the flame energy of V0 testing. To achieve 5VA rating, the material must not only self-extinguish, but also must not ignite cotton from any drippings and not have a burn-through hole. It is no wonder why the 5VA rating is needed for enclosure materials as a means to prevent the spread of an electrical or fire hazard. And finally, this table shows 3 different colored FRB series materials that meet the demanding UL 8750 requirements for luminaire enclosures. FRB is one of the very few thin convertible materials to meet all these requirements. Even meta-airmid papers, which are considered to have fairly good flame-resistant properties, do not meet all of these requirements. Okay, off to you, Joe.
Thank you, David. 3M has an excellent reputation as a tape supplier for consumer and industrial applications. Many adhesives and tapes are used in the construction of luminaires. Let's review some key product families for industrial adhesives and tapes. When people consider why use adhesives, they consider the many benefits of adhesives over conventional fasteners. Then they begin to realize, why not use adhesives? Tapes relieve the stress at the bond line where two dissimilar materials expand and contract by removing pinch points. They assist in removing production steps with the welding process and assembly process. By removing mechanical fasteners, new design elements are introduced never thought of before by offering new aesthetic options. Here you can see a comparison of different types of adhesives and their load-bearing characteristics if you are looking to replace mechanical fasteners in your lighting application. We will go up this curve in discussing some of the different 3M solutions with the emphasis on PSAs and foam tapes. The overlap shear column in PSI that PSAs and foam tapes offer generally meet these requirements for lighting design. So when discussing pressure-sensitive adhesives, also known as PSAs, transfer tapes are good for bonding to flat surfaces with thin bond lines. There are different adhesive families which can be selected to match intended substrate surfaces and environmental conditions for the application. These thicknesses range from 2 to 10 mils, with 2 and 5 mils being some of the most popular options. When selecting a PSA, we will assist you with the right product by understanding the surface energy of your components. For instance, if your metals are powder coated, we would review a low surface energy bonder such as the 300 LSC line of materials. One application for adhesive transfer tapes is applying the PSA onto the previously covered FRB series materials. The PSA aids in holding the FRB in place during its use, or simply as a third hand while either a mechanical fastener or assembly system is pinched in place. Since it is so thin, it helps in designing low-profile components with tight tolerances. This laminated assembly is easy to assemble, offers instant tack, and can help in eliminating fasteners while also sealing fixtures. In December of 2016, The 200 MP series of PSAs with 467 MP in mind, the high temperature 9082 transfer adhesives received component listings for temperatures of 100 C or more, thus allowing luminaires to utilize our transfer adhesives without the need for screws. This allows for a lower cost design and construction, as well as faster throughput in the production environment. Double-coated foam tapes are good for bonding rough or irregular surfaces. There are different products capable to match various combinations of substrates, functions, and environments. These can also be used in cases where light escapes the luminaire. The gasket can prevent the light leakage. One of the most used materials is our VHB line of products. VHB tapes offer better bonding and sealing than mechanical fastening techniques, including welding, while improving the look of your lighting system by hiding joints. VHB has unique viscoelastic capabilities to remove stress in bond lines as well as dampen any sort of vibration. Its acrylic chemistry offers some of the highest bonding strength for demanding applications. One of the great things about using VHB tapes is that they bond and seal at the same time and are very durable. Their ability to bond plastic and metal is also significant for some lighting designs. The acrylic design is through the foam, allowing for watertight seals when necessary. VHB is currently used in many markets, including electronics, automotive, marine, aerospace, general industrial, and of course, lighting. The last product area to be covered today is electromagnetic interference or radio frequency interference management. Although LEDs operate with direct current, there are lighting controls and dimming circuits with troubling high frequencies. In addition to thermal management for LED lighting, we also supply materials for EMI RFI management, such as conductive transfer tapes, gaskets, shielding tapes, and absorbers for your lighting design. Should you have any electrical interference concerns, we have the solutions for you. Before handing it off to Brent, I want to conclude by saying that 3M has many offerings for LEDs to include robust adhesives and materials solutions that deliver thermal conductivity, electrical insulation, EMI RFI shielding, and flame-resistant barrier protection. As you begin to consider the thermal management materials you will use in your design, it's important to work with an experienced converter. That's where Brent and Fabrico come in. Off to you, Brent.
Thanks, Joe. You've just seen some solution-driven materials 3M provides for your next LED application. At Fabrico, we also take that same solution-driven approach. We're there for you at the start of your next project to the finish. That process starts with finding the right materials or combination of materials for your application. In most cases, we can provide prototypes or samples materials for you to test. Then we'll work with you on the optimal format for those materials in order to provide the best assembly solution for your manufacturing plant. Fabrico has a wide range of converting capabilities with a variety of versatile equipment located at all four of our manufacturing plants in North America. But the most important capability is our industry-leading engineering staff. Their vast converting experience along with our abundant capabilities allow us to provide the highest quality materials at the most competitive pricing. Fabrico's testing laboratories can deliver a wide range of testing capabilities in order to determine a material's properties and capabilities. This allows us to explore alternatives for customers early in the design phase before any sizable investments are made. In the coming slides, we'll review some LED case studies where Fabrico and 3M solutions were used. In each of these, we help design engineers examine trade-offs and explore alternatives in materials and adhesives. In aerospace, everything is driven by size, weight, and power. Microelectronics get smaller, faster, and more complex with each new design. In this application, The key to our customer's success was selecting a low-density thermal interface material to complement their substrate's characteristics. The TIM also had a low coefficient of thermal expansion. The developed solution was die cutting a thermal interface pad to a very small, intricate shape. We also added a tab to the liner to make it easier to apply by hand. In outdoor lighting systems, high brightness LEDs allow for maximum illumination for safety and other considerations. We die cut a thermal conductive, electrically insulating polymer pad with a liner and conductive adhesive to meet the customer's design requirements. This manufacturer of LED-based emergency lighting systems needed to provide excellent dielectric insulation in order to keep two high-power feeds isolated. They also required thermal conductivity to ensure a long and bright life cycle. So we die cut a dielectric insulation material to isolate the two high-power feeds. We also created a pre-creased enclosure with a 3M thermal interface material that could be shipped flat and then added tabs to help in its final assembly. In this application, FRB material was needed to meet UL requirements. A thermal interface material was also required to redirect heat. Fabrico die cut both materials, added a PSA to the FRB material. LED headlights are becoming very popular because they allow design engineers to create new shapes and forms. In addition to thermal conductivity, this application also required sealing to ensure that the headlights could stand up to the harsh environment of normal automotive use. In summary, we look forward to helping you meet the environmental and functional requirements of your specific application. 3M and Fabrico will work with you in selecting the right materials, the right adhesive, and the right converting capabilities for your LED application. So next time you start a new lighting project, please keep 3M and Fabrico top of mind so we can help you create the most robust, cost-effective LED assembly possible. I will now turn this back over to Stephen for question and answers.
Okay, gentlemen, thank you for that presentation. So let's go ahead and take a look at some of the questions from our audience today. Our first question, when an LED light fails using a TIM, is there a possibility of a fire?
I can take that, Steve. Yeah, most of these materials, just about all of them, meet UL vertical burn 94V0. So they are self-extinguishing. They would not contribute to a fire.
Okay, great. Thank you. Our next question is, I've always used thermal grease as my interface material because of its good thermal performance. What kind of thermal performance can I expect from an acrylic or silicone pad?
I'll take that one also, Steve. The silicone pads, most of the greases out there are in the 4 watt per meter Kelvin range in conductivity. And we can offer 4 watts, even higher, as much as 5 watts with a silicone pad, and as high as 3 watts with an acrylic pad. So very comparable.
Okay, thank you. Next question, do flame barriers interfere with transfer heat? Is it a critical issue for LEDs?
Okay, yeah, this is Dave. I can take that one. The FRB is placed between the board and the secondary lens, so typically it's not in the path of heat transfer out of the enclosure. On the other side, there will be a high thermal conductivity pad that helps direct it to the housing of the enclosure. So the answer is no. The flame barriers, the way they're used and where they're placed, don't prevent the heat from exiting the LED.
Okay, thanks, David. Next question, can solder be used in thermal management?
I can take that, Steve. It can be used. It's a very good thermal conductor. However, very difficult to use in a high-scale production process because we're heating the stuff up. It's only going to flow while it's at temperature, and as soon as we remove that temperature, it's going to solidify. It just makes for a very difficult production situation.
Okay, thanks, Mark. Next question. We're working with an LED-based headlamp in a truck. Should I be worried about heat dissipation if I'm using high brightness LEDs?
Yeah, absolutely. We can't let them get hot if they operate at too high of a temperature. The first indication you're going to get is a color shift in the headlight. It's going to become more and more yellow. And then at some point down the road from operating at too high of a temperature, it will just fail, and you'll have to replace the bulb.
Okay, great. Thank you. Next question. Someone says, I need to combine thermal management and electrical insulation in an LED application. Can you suggest what type of TIM might work best?
Hey, this is Joe. I'll take that.
Okay.
Yes. Yeah. So from thermal interface pads, they've got a high dielectric strength, and so they do a very good job, of isolating live current. But the silicone TIM dielectric strength is a little lower, and acrylic TIM constructions, which are higher. So the acrylic TIMs should be evaluated for the maximized insulation characteristics.
Okay, thanks, Joe. Next question, is airmid paper good for thermal management as well as electrical insulation?
Okay, this is Dave. I'll take that one too. Airmid's a good electrical insulation, and it has a good flame rating. It has a UL 94 V0 flame rating. But I expect that the question is, can you use the airmid paper as a barrier to meet enclosure requirements per the 8750? And that it does not have all of the required properties such as CTI or glow wire ignition or the 5EA rating. So yeah, it's a good electrical insulation, but for this application, it doesn't have all the needed properties.
Okay, great. Can you provide porosity, breathability, and heat sinking regarding your films and tapes? Would one of you like to take that one?
Well, they're not porous. I guess the comment that I would make is both your gap pad materials and your thermal attachment tapes, your greases, your epoxies, anything that's thermally conductive would have no porosity at all. So I hope that answers the question. They don't breathe because if they did, they would not conduct thermal energy very well.
Okay, great. Next question. I'm working with batteries in an electric vehicle. Is there something I can use to dampen vibration and dissipate heat? And is there a foam material that would work?
And we're back to the air issue. Anything that would be a dampener would likely be cellular. And, air is what we're trying to replace with a thermal interface. So it's hard to get vibration damping and thermal conduction at the same time. You do get a certain degree of vibration damping with the thermal materials, but it's not going to be the type of cushion effect that you get from a cellular construction.
Okay, great. Okay. Someone is asking, where can they get your 3M metal tapes?
Well, I'd be happy to answer that.
Well, Brian, I was going to say you, so go ahead.
Yeah, Fabrico or EIS, depending on what your format would be. I mean, we can work with you in any number of ways as far as combining. A couple of questions ago, it came up as far as can you get double action out of a material? And in a lot of cases, you can, but we can always combine two materials to give you, let's say, dielectric and that thermal management or interface action. So there's a lot of things that we can do. When it comes to metal tapes, we can die cut those, we can split those for you, and we can sell them in pretty much any format you want. So yes, Fabrico and EIS can help you there.
Okay, great. All right, let's take a look at one more question here. What temperature can VHB tape stand up to?
Yeah, this is Joe. I'll take that. So VHB will run continuously at 250 F, as an average, but it can take short-term spikes up to 300 F for the usage. Now, we do have some series of VHB tapes that'll go over 400 F, and the reason for that is mostly for going through a powder-coated oven. So if in the event you need to actually do some pre-assembly before paint, you can actually use our 46 series of VHB tapes to bond all your components together in the actual fixture as opposed to the LED strip, and so that you can actually push that whole metal unit through the powder-coated oven and have a tape that will withstand the higher temperature in that environment.
Okay, great. Okay, we're going to wrap up the Q&A right there. Once again, thank you, gentlemen, for your presentation and your time today. And thank you to all of our members for joining us today. Take care and have a great rest of your day.